Hello, let's continue electromagnetism. So, our topic for today is force on a current carrying conductor. Whenever in a magnetic field of permanent magnets, a current carrying conductor is placed, a force is experienced by the conductor. This force is perpendicular to both the field and the current. For example, if I place a current carrying conductor that is going into the page in a permanent magnetic field, you clearly observe that the force on the wire will be acting downwards. The question is, how do we got to know that? For that reason, we use something called the Fleming's left hand rule. Place your hand like this. The thumb will be directing towards the force. The first finger will be directing towards the magnetic field, and the second finger will be directing towards the current. An easier way to memorize it is by FMC, force, magnetic field, current, FMC. Whenever we are using the Fleming's left hand rule, magnetic field and current are always known. The unknown entity is always the force on the conductor. This is used in DC motors and force on a charged particles moving in the magnetic field. Let's look at some cases. In case number 1, there's a magnetic field from north to south. Place your first finger in the direction of the magnetic field. The current is going into the page, which is represented by a cross. The force is acting downwards. In the second case, the magnetic field is in the same direction from north to south, but the current in this case is coming out of the page that is indicated with the dot. Your thumb will be pointing upwards, that means the force on the conductor is upwards. For example, if I flip the magnetic field, now the magnetic field is from right to left. The current is into the page, and the force in this case is acting upwards. For the fourth case, the magnetic field is still from right to left. The north is on the right and the south is on the left. You place your first finger in that direction. The current is coming out of the page, so your middle finger will be coming out of the page. The thumb will be directing downwards. Therefore, the force is acting downwards. Well now, the Mac is thinking something. He's basically thinking that what can be done to increase the magnitude of the force on the conductor. Well, for that reason, Mac, you can do 3 things. First, you can use a stronger magnet. Second is you can increase the current in the conductor. And third, you can increase the length of the wire that is present in the magnetic field. That means you need to make more loops.